Good afternoon, students, and welcome to your behind the scenes tutorial on your disciplinary perspectives assignment. I, of course, am your professor, Dr. Rob Steffen, and in this module, we've been looking at classical antiquity through the lens of a natural scientist. Experiments, natural laws, theories, all that great stuff. But how do you actually put together an experiment in the style of a natural scientist? Well, let's go ahead and walk through an example together here, right? Now remember, you're going to be conveying your experiment in written form, but this should give you a good example of some of the major steps along the way. So let's go ahead and fire up the projector, turn down the lights, and find out what a natural scientific experiment is all about. Okay, so for the sake of this example, let's go ahead and assume that I'm an ancient Roman architect, and I want to test which building material I'm going to use to construct my new harbor. The burgeoning population of Rome has to eat after all, and this will allow grain ships to dock on Italian shores and get their goods into the heart of the empire. I'm worried, however, because I know the building materials will get wet, and I'm concerned that will make them weaker and, possibly cause them to break. And as a good Roman architect, I'd like to try a little experiment before committing to my project. Now, the first thing I'd do here is clarify my question or goal in this experiment. And in this example, our goal is to test how being soaked in water affects the structural integrity of our possible building materials. Next, I'd select my variable. And the variable is the aspect of the experiment that changes each time it's tested. Everything else we're going to try to make exactly the same. Those are the constants. So in this experiment, my variable is going to be the type of building material. I'm going to test 3 different options here: wood, brick, and concrete. And all 3 of these have been used in different types of Roman buildings. So I want to see which one's going to do the best in a water-filled setting. Now, after selecting my variable, I'd like to describe the methods of the experiment itself. So for my project, the emperor has given me a small budget here, but a lot of time. So pro tip, in your own experiment, feel free to come up with your own kind of conditions, right? How long you have, how much money you have, you get to decide that yourself. But because I have limited funds, I can't go ahead and build 3 full-sized harbors, each one out of a different material, wait a year, and see which one's holding up the best. Honestly, that's a ridiculous thing to do anyway, right? You know it, I know it, we all know it. Instead, I'm going to start my experiment by getting the same amount of each material. I'm going to choose something a little bit more manageable in size. And I want to very clearly state what that size is. And in this case, I'm just going to make something up. We'll go with something like a foot wide by 6 feet long by 6 inches thick. We'll use the same amount of each material in those dimensions. Next, I'm going to go ahead and test how strong each of those materials are on dry land. And I'm going to do that by placing weights on top of them, step by step, until each cracks, and I'll record how much weight that takes. So just in case I'm using these these materials for another project in the future, right, on dry land later in my career, I'm going to have that useful information available. Now, next, I'm going to go ahead and place each of these underwater for, we'll say 6 months in this experiment, right? I'll want to note that each is completely submerged, and I'll want to make sure that it's all salt water. These are going to be sea-based harbors after all. Now, side note here, right? These kind of things, complete submersion, salt water, the type of water, that sort of thing, these are the kind of details that you'd want to note in an experiment of your own, right? Being clear about the details is half the job of being a natural scientist. Now, finally, after 6 months, I'd pull the materials out of the water and start testing their strength once again. Same manner of doing it this time, right? Placing weights step by step until each cracks, crumbles, or breaks. Now, not only will this tell me how much weight each waterlogged material can support, it's also going to tell me how much the strength of each material has deteriorated from its dry form. Now, for our basic experimental setup, we're good to go, right? And if you produce something like I just went through there, I'm going to be perfectly happy. But you can also probably imagine a million different ways that you could build on this, right? Build on top of it. So for example, you could put multiple examples of each material in the water and test how they hold up after different amounts of time, right? 3 months or 6 months or 9 months or a year. And you get the sense then for how longevity of being in water affects structural integrity. You could also use different amounts of each material to see how much of each you'd need so that they can all hold the same amount of weight, right? And then once you know how much that is, you could price them out and you'd get a sense for maybe the cost effectiveness of each building material. So to sum up, right, you want to make sure that you're clear about what your question is. Make sure you clearly identified your variable, and remember, you only want one variable at a time. It's also useful to know what the controls or constants are, right? That is, state some of the things that are going to be the same in each manner of testing. Then go ahead and describe your experiment in detail, step by step. The more detail here, the better. Ideally, you'd like someone else to be able to recreate your experiment, even if you weren't around to tell them how to do it. Finally, consider what some of the next steps might be. Now that you've conducted the first version of the experiment, right, what else would you want to know? And how might you go about discovering that information? Now, if you focus on these things, there's no doubt that you're going to be a grade A natural scientist. So farewell, scholars of antiquity. Now go forth and conquer.